Alright, today's video is going to go ahead and cover rate conversions, which can be kind of tricky. There are really two notes. One, when multiplying, if you want to eliminate a unit, you want to multiply by the inverse to eliminate that unit. And two, when you multiply, you want to multiply by a ratio that's equivalent, and you'll kind of understand that as we get through this. So the first part here is just to read the problem. A sheet of glass has a density of 2.5 grams. The fraction line means per centimeter cubed. So we got an exponent here. So 2.5 grams. I'm putting the variables in just so that you can see. It's not necessary for you to do that. Per 1 centimeter. It doesn't say 1 centimeter, but it's implied that it is 1 centimeter. Okay. So we're going to multiply in order to change the units. And so we want to go from it's asking us what is the density of the glass in kilograms per meter. So we're going from grams to kilograms, so we got to change that unit, and we're going from centimeters to meters, so we got to change that unit. So let's go ahead and change the gram to kilogram unit first. We're going to multiply, and grams is in the numerator, so to eliminate it we're going to multiply by the inverse. So if grams is in the numerator, the inverse would be multiplying grams in the denominator. And we're just trying to get rid of the gram part, not the 2.5. The 2.5 is fine. We're gonna leave that. We're gonna multiply by 1 gram, and that'll cross out. That'll divide out to 1, which means it'll be eliminated because of the multiplicative identity. In the numerator, we're gonna put kilograms because that's the unit that we want to get into. And then we just got to come up with the ratio of what's equivalent. That's the second part. We got to make sure we're multiplying by a ratio that's equivalent. So what's equivalent here? Like how can we set this up? So 1 kilogram is equivalent to 1,000 grams, and I looked that up on Google using a rate conversion sheet. So that's an equivalent rate relationship right there. 1 kilogram is equivalent to 1,000 grams. Those are equal weights. So we've got the grams that are we've converted our grams to kilograms. Now let's go ahead and convert our centimeters to meters. So centimeters is in the denominator. So the inverse here. The inverse, I'll go ahead and underline this. The inverse would be multiplying centimeters in the numerator, and we're going to multiply centimeters cubed. Okay, that's important. Which would mean that we want meters in the denominator. Okay, so meters cubed. And then we got to come up with a relationship. So how many centimeters are in 1 meter? There are 100 centimeters in 1 meter. So here's the math with the symbols. Now I'm just going to multiply the numbers. So we got 2.5 times 1 times, and I'm going to put this in parentheses, 100 cubed. And then in the denominator we've got 1 times 1,000 times 1. So I'm just rewriting this without the letters. And we get 2,500. So let's go ahead and see if that's correct. And it is correct. Alright, so let's go ahead and move on to the next question. So the question reads, the inclination tilt of an amusement park ride is accelerating at a rate of 2,160 degrees per, that fraction line means per, 1 minute. And you don't see the 1, but it is a minute. So I'll go ahead and put the 1 in decimals. What is the rate's acceleration in degrees per second? So when we look at this, we're only having to change one of the units. Degrees is fine. We only have to change seconds to minutes, or from minutes to seconds. So we're going to go ahead and multiply. Minutes is in the denominator, so we're going to multiply minutes in the numerator, and that's minutes squared. And then we want seconds to be in the denominator. And then we just got to come up with the relationship of minutes to seconds. So there's 1 minute, and the relationship for seconds would be 60 seconds, because there's 60 seconds in 1 minute. So that's the relationship between the two. Now I'm going to go ahead and multiply these without the numbers. So in the numerator we've got 2160 times 1 squared. And in the denominator we've got 1 squared times, and I got to put it in parentheses just because that's the way I practiced. 60 squared, which gives us 0.6. Bada boom boom. Bullen rose on a rows on a crew team. Her team rows their boat at a split rate of 2 minutes per 500 meters. What is Bowen's team's rowing rate in meters per minute? So here it's just putting meters in the numerator and minutes in the denominator. It's just flipping the fraction. So let's go ahead and flip the fraction. That would be 500 meters over 2 minutes. And then we just got to do the math, which is 500 divided by 2, which is 250. So 250 meters a minute. Okay, so here we have the last question. The batting Wang Zhu-ying uses to fill quilts has a thermal conductivity rate of 0.3 watts per meter per degrees Celsius. So I've got that right there in the Desmos. What is the batting's thermal conductivity value in watts per 1 centimeter? So it looks like we're just changing meters to centimeters. So let's go ahead and multiply here. We want meters to be in the numerator because we're trying to eliminate it, which means centimeters would be in the denominator, and the relationship between 1 meter and 1 centimeter, 1 meter would be 100 centimeters. And now we're just going to go ahead and quickly do the math. So 0.03 times 1, and we're dividing that by 1 times 1 times 100. So we get 0.0003, and that's how you do it. That's rate conversions for you. Don't forget the notes. Shalongo signing off.